What a research team at the Cern Nuclear Research Center is now planning is not only explosive, but also extremely risky: the transport of antimatter in a truck. What the aim of this experiment is and how destructive this plan really is, information on this topic now on Clixoom Science Fiction. Welcome. The discovery of antimatter 85 years ago was a real sensation. Since then we have known there is also an antiparticle for each particle. In the case of the electron, for example, this is a positron. And not only in nature is the interaction between matter and antimatter of great importance. Nowadays antimatter can even be produced artificially and is extremely useful for medical diagnosis, for example. But the plan of the Cern physicist Alexander Obertelli and his team makes you hold your breath. 1 billion antiprotons are to be stored in a container and transported several hundred meters so that they can be used in an experiment. More specifically, the antimatter will be fired at weakly radioactive atomic nuclei. According to the critical voices, this experiment has an extremely destructive potential. And yes, antimatter is a truly explosive thing. Then, when it meets matter on the spot, they annihilate each other. 0.5 grams of antimatter would be transformed into pure energy and release as much energy as the atomic bomb Fat Man. In August 1945, the Japanese city of Nagasaki had been largely destroyed. The atomic bomb had developed an explosive force of 21 kilotons of TNT. Of course, the whole experiment also has a purpose. The Cern research team wants to collide antiprotons with neutrons and protons and then analyze the resulting decay products. For about 10 years now it has been known that atomic nuclei do not always form a kind of clump of neutrons and protons, but also neutron clouds, also called halos, or denser neutron shells. Researchers had discovered this in the case of the radioactive beryllium, for example. The planned Cern experiment with antimatter could thus reveal whether there are other such nuclei. In the best case scenario, this could even clarify how we can imagine their inner life. The production of antiprotons is nothing new for Cern. This is achieved by firing fast protons at a massive metal block. Electromagnetic fields then strongly slow them down so that they can be stored. Afterwards, the antiprotons are isolated from the environment by a vacuum. However, Obertelli's goal is to achieve an order of magnitude that is comparable to anything that has not been achieved before. So far, the record of antimatter experiments is 10 million antiparticles stored for a short time, but the experiment now planned has a budget of 1 billion. The researcher himself is quite relaxed about this. According to him, their annihilation would not release more energy than it takes to lift an apple. And further, the radioactivity that would be released would be relatively low. But how does the Cern research team plan to produce this enormous amount of antimatter and store it over a period of 1 month? This is precisely where the big challenge lies. Obertelli and his colleagues want to build an electromagnetic trap that is 70 centimeters long. This trap will then be cooled to minus 269 degrees Celsius inside a superconducting magnet weighing several tons. The vacuum, which is intended to prevent the antiprotons from meeting air particles, must be 100,000 times thinner than that of the LHC accelerator. If the research team succeed in storing the antiprotons, they could be transported in a vehicle to the neighboring laboratory. Here, in the neighboring Isolde ion beam facility, the antiprotons would collide with the radioactive ions. Obertelli and his team are optimistic. The development of such a technology could open completely new avenues in research. For example, the scientist sees its future as a promising source of propulsion for space travel. Click here for another fascinating topic about the LHC. Portal to a new kind of physics has been opened, and subscribe to our channel for all updates on Cern. Stay tuned and see you soon.